Hi parents, I just wanted to do a video for you about the area model for division. I know I did one for multiplication. A lot of people said it helped, so I'm going to do one for division as well. There is a point the other day where I broke down and I was like, I just don't understand why I can't teach them the standard algorithm. And so I get your frustration, I completely understand, but the state of Texas says that this is the way that we need to teach them conceptually, and so that's what we're doing. So I'm going to do one with the area model and then one with the standard algorithm so that you can see the relationship between the two. It's going to have way more steps and it's going to take a lot longer. But when they transition into the standard algorithm, they will have a better understanding conceptually of what they're doing versus the way that we were taught. So you start with your divisor on the side, which is our 3, and then your dividend on the bottom, which is 4,354. And it's kind of we're working the area model backwards. So multiplication and division are reciprocal operations, meaning they're the opposite of each other, inverse. And so you can use one to undo the other, and so on and so forth. So logically, when we would start over here, we'd say, okay, we're starting with the first place value. I've got 4. How many times does 3 go into 4? Well, the terminology of 3 going into 4, that's not actually what's happening. Division is repeated subtraction. So I kind of try to not use going into, but that's what we were taught, so that's what I'm used to saying, so I kind of have to break myself of it. But 3 goes into 4 one time. 1 times 3 is 3. Subtract 1, bring down your 3, okay? Well, what they never told us, and what I didn't realize until I went to school to be a teacher, and y'all may have, it never made the connection, was right here, we're not actually subtracting 3. Because of our place value system, we're actually subtracting 3,000. And this is not actually just a 1, you're actually saying 1,000 times 3 equals 3,000 and subtracting that and going on. So essentially, the new problem that you're doing is 1,354 divided by 3, okay? So, to get the kids to understand that, we do it like this. Now, a lot of the kids have a hard time going, okay, this is a 4,000. What times 3 will get me close to 4,000? For some reason, they don't go, oh, 1,000. So, I teach them something called friendly numbers. Which is where they take their divisor and they multiply it by a list of numbers, basically. So they do 3 times 1,000 equals 3,000. 3 times 500 equals 1,500. 3 times 250 equals 750. 3 times 100 equals 300. 3 times 50 equals 150. 3 times 25 equals 75. And 3 times 20 equals 60. Now, I know that this sounds just crazy, but for some reason, some of them just, it doesn't hit them. Some of them it does, so they don't need friendly numbers, some of them do. So this is how the friendly numbers work. If I'm looking at 4,354, which of my friendly numbers can I subtract to take the largest chunk out of my dividend? Well, I can use 3,000, so I'll put 3,000 here. How did I get 3,000? 3 times 1,000, so my 3's already here, times 1,000, and this ends up being part of our answer. So our quotient will be up here. This one piece is called our partial quotient. I'll subtract, which now our new problem is 1,354 divided by 3, which is the same thing that's now going on over here, okay? They'll close in their box and we'll move on a step farther. So, thinking about 1,354, which of my friendly numbers can I subtract? Well, 1,500 is greater than this, so I could subtract it, but then we're going to be, you know, at a negative number. We don't need to do that. So we will use 750. So 750, how did we get 750? 3 times 250, subtract 750. Can't do math. 604. All right. So I'll hop back over here to the standard algorithm. So for us, we'd say how many times does 3 go into 13? 12 times, and I know that 4 times 3 is 12. Subtract, bring down my 1, bring down my 5. Okay, so it doesn't match up here because we're going to have additional steps in this one. If they didn't use friendly numbers and if they could reason with the 13 and the 3 right here, where they could have said 13, what times 3 will get me close to 13 without going over? Well, 4, and so on and so forth. But friendly numbers are better for those that can't do that reasoning. So 604 is our new one. I can't use 750 again, it's too much, so I'll use 300. 300 I get by 3 times 100 minus 300. 304, scoot this over. I can use 300 again, 304. I get 300 by multiplying by 1. I'm left with 4. Now some of them will go, okay, well 4 is my remainder. Well no, because your remainder cannot be larger than your divisor because you can still subtract another set of 3 from that. So 3 times 1, 3 times 1 would be 3, minus 3 would be 1, and then this is your remainder. So to get their quotient, they would then add all this up, these partial quotients, and it would be 1,451 with a remainder of 1, R1. And this is their answer, okay? And then over here, I mean, and so there are some kids who can do it in fewer steps and it looks more like this. It's just in a horizontal format. The kids that need the friendly numbers because they just loading, don't know, they need the friendly numbers. So if you have any questions when I upload this video, I will also share my email address. Email me if you need anything.